Hey guys, I am going to do a review for everything you're supposed to know for Unit 12 before you take the test. So let's take a look here. All right, there are going to be three main things that you need to know how to do. One, you need to know how to find a reference angle. Two, you need to know how to find a trig value with a reference triangle. And three, you need to know how to find a trig value using the unit circle. So those are three basic things that you need to know how to do. So if you can do those three things, you are going to ace this test. You are going to be ready. Now, before I can teach you any of this, I'm just going to go back and do a quick review and make sure you guys are solid on how to label angles on the coordinate plane, all right, in radians. So when we're talking radians, maybe I want you to go label the angle 5 pi 6. All right, before I even start, have you guys ever seen a calzone? I've actually never eaten one, but I know what they are. They're like almost like a pastry, but they're filled with stuff. You know, I've seen like pizza calzones. I think there's other things, but they're always in this shape, right? And what if I say I'm going to eat 5/6 of that calzone? Well, going back to elementary school, you guys, how do you do fractions? The bottom number tells me how many pieces. So I'm going to take this, I'm going to split it into 6 equal pieces. And how much am I going to eat? I'm going to eat 5/6 of it. So 1, 2, 3, 4, 5, 6. That's what we're talking about, okay? When we do 5 pi 6 on the coordinate plane, we're not counting actual solid pieces. What we're counting is the angle measure. That's the angle that I'm creating here. That's 1 6, then 2 6, then 3, then 4, then 5. It's found the same way because we're dealing in fractions. And half the circle, the same shape as my calzone, is equal to pi radians. That is the angle measure from here all the way around is pi. All right. So if I want to do 5 pi 6, I'm doing the same kind of idea here. Is I'm going to split this top half. If I'm looking just at this top half of my circle, I want to split it into 6 equal pieces. All right. Well, it's already split a half there for the y-axis. 6 equal pieces. Now I count. 1, 2, 3, well, I went too far. 4, 5. And this is where I land. That angle right there is 5 pi 6. Okay. One that tends to kind of throw some people that I just want to show real quick is what if I want to do 5 pi thirds? Okay. How do I take this top piece and split it into thirds? When we're split into thirds, you have to ignore the y-axis, okay? To split into thirds, I would take, okay, this, and I would split it about here and about here. Now can you see that I have 3 equal pieces? So when you do thirds, you have to ignore the y-axis. It's not part of my slicing. Okay, so let's count. There's 1, there's 2, there's 3, but I need 5. So what do I need to do? Yeah, I need to keep going. I need to split the bottom half of my circle. So I'm going to do the same thing and split it down here into thirds. So when I count, I go 1, 2, 3, 4, 5. And I land right here. This would be the angle 5 pi thirds. Okay, that was just a quick review on how to label radians on your coordinate plane, because we have to know how to do that to do this. All right, so starting off, what's the first thing I need to know? How to find a reference angle. And I give you 3 basic steps. So we're going to follow those 3 steps right here on example 1. Find the reference angle for 5 pi thirds. Step 1, draw the angle. Well, guess what? We just did that one, so we can do that. That was my example just a second ago. Okay, I'm splitting it into thirds, so I need my pieces to be in thirds. So let's do that. Here we go. I'm going to split it about here, because that makes it pretty close to 3 equal pieces, and down here, and down here. So if I split this, can you see that the top, or pi, is 1, 2, 3 pieces, and the bottom is 3 pieces. So now let's count. Where's 5 pi thirds? 1, 2, 3, 4, 5. This angle right here is 5 pi thirds. Okay, step 1 done. Step 2, see the 2 angles that are formed with the x-axis. All right, what is that saying? Here's the x-axis. What 2 angles do I see that's formed with the x-axis and my terminal side? Well, there's two different ones. I need different colors here so you guys can see. There's this angle right here. See my green one? And we'll do the other one in red. And then I have this bigger angle right here. Those are the two angles that are formed with the x-axis, the x-axis and this terminal side. This little green one and the red one. It says find the measure of the acute angle, the one that's smaller. Which one's the acute angle? The green one, okay? How do I know the measure of that? How many pieces was it? Remember, I divided this into what? Thirds. And how many pieces is just this section? It's only one piece, or 1/3, so my reference angle would be pi thirds. The measure of this angle right here is pi thirds. That's what I'm finding when we talk about a reference angle. All right, let's try example 2. Find the reference angle for negative 13 pi fourths. Step 1, draw the angle. Okay, I'm splitting it into fourths, so here we go. This would be the halfway, and then in half, and half again. So I've split the top, I've split pi into fourths, now I split the bottom into fourths. So can you see I have 1, 2, 3, 4 on top, and 1, 2, 3, 4 on bottom. Okay, I'm split into fourths, and I want to count 13 pi fourths, but in the negative direction. Remember, negative's going to head downward in a clockwise direction. So I start at 0, I start counting. 1, 2, 3, 4, 5, 6, 7, 8. Keep going. 9, 10, 11, 12, 13. That is where I end. So this piece right here, this is my terminal side. So this is the marker for the angle negative 13 pi fourths. Okay, we found the angle. Now we want to find the measure or see the two angles. So see the two angles formed with the x-axis. Here's my x-axis. Where are the two angles? I can see this red one, this smaller one here, and then the green one, this is the bigger angle. Which one do I want to label? The acute, the smaller one. Well, what is the measure of this little bitty angle? What was I counting in? I was counting in fourths, and how many pieces is this? It's only one. So this would be 1/4, or what would I say? Pi fourths would be my reference angle. That's what a reference angle is. It's saying what is the measure of this little angle right here that is formed with the x-axis. And that's important because we're going to use the reference angles to be able to do problem number 2, or the second part you need to know how to do. Finding trig values with a reference triangle. We're going to draw the angle, we're going to draw the reference triangle, and we're going to label my triangle using one of these special right triangles. Do you guys remember these? These are all right triangles. They don't have the little right angle in here. Okay, this one is my 45, 45, 90, and it has sides 1, 1, and square root 2. This one is my 30, 60, 90. Make sure you get 30 down here in the bottom. Short side is 1, hypotenuse is 2, long leg square root 3. All right, this one, the bottom is going to be 60, and this is important. These bottom ones, they are going to be my reference angles. They're the important ones, okay? So make sure you kind of keep track of those. And up here is 30, so short side 1, hypotenuse 2, and long leg square root 3. All right, label the reference angle, and we're going to use SOHCAHTOA. What does SOHCAHTOA mean? Let's just do a quick reminder. That means sine theta is going to be opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. Tangent theta is opposite over adjacent. Let's go with the other 3 trig functions that you learned, which are cosecant of theta, and is the reciprocal. It's hypotenuse over opposite. Secant theta, again the reciprocal, hypotenuse over adjacent, and cotangent theta, adjacent over opposite. Now, at this point in the video, if you've just been sitting there watching me, here's the deal. You can use this on your test. So I strongly recommend that you start writing. I would make sure you have these trig functions down, where you have them where you can use them. Make sure you have these measurements on the triangle so you can use this on your test. All right, so let's look at my examples. I'm going to go straight through all of my steps. Are you ready? Example 1. Find tangent 5 pi 6 using a reference triangle. Okay, first I'm going to draw the angle. So let's draw an XY axis. How do I draw 5 pi 6? Well, how many pieces? I'm splitting into 6 pieces for the top. So split the top into 6 equal pieces. Let's see how well I can do this. So count them, 1, 2, 3, 4, 5, 6. If I count that y-axis, I'm 6 equal pieces. Now do the bottom. We need the bottom split. Okay, now go find 5 pi 6. So let's count. Here we go. 1, 2, 3, 4, 5. Boom. This is the one I want. This is where 5 pi 6 is. Okay, we found the angle. Step 1 done. Draw a reference triangle perpendicular to the x-axis. Okay, you guys, I've seen some of you draw these reference triangles and you face them the wrong way. All right? The right angle has to be on the x-axis. Okay, so when you draw your right triangle, you have to have, when you draw it, you have to have a right angle made with the x-axis either over here or over here. Some of you guys are trying to draw it up there on the y-axis. No. So coming down here to this example, I make a triangle with the x-axis. It has to connect to the x-axis, not the y. Okay, so this little bitty triangle is the one I'm going to use. Now, how do I know which one of these to use? All right, here's a good trick. Pi force is equal to 45 degrees. So is this a 45-degree angle? No, because I am in sixths. Do you see that? I went into sixths, not into fourths. Remember, this reference angle is one piece out of 6, so this is the same as pi 6. I don't want to use this triangle. This one right here represents pi 6, which is 30 degrees. All right, that's what I want. If I'm in 6, see that? I'm in 6, and this is 1/6 right here. That's my reference angle. That's the same as my 30-degree angle, so this is the one I want to use. Guess what this one's going to be? This one's going to be when we're in thirds, and that's going to be my 60-degree. So see how this triangle matches this one? Now all you got to do is go plug in those numbers. Okay, this is 1, this is 2, and this is square root 3. Okay, but don't forget to pay attention to positive negatives. On the XY axis, if I go left, this is negative. If I go up, that's positive. And the radius or the hypotenuse will always be positive. Don't ever mess with that number. Okay, you have them labeled. Done. Okay, now label the reference angle as theta. So see these ones I've marked here? Those are your reference angles. The one down here in the x-axis. This is your theta. That's your theta. And why is that important? Because you need to know which side is the opposite, the adjacent, and the hypotenuse. Someone once asked me, will the y going up and down always be the opposite? I said, yes, it will. Because your reference angle is always right here in the touching the x-axis. So that's going to make the y value always your opposite. Okay, this one's my adjacent and this one's my hypotenuse. All right, so now that I've done all that, now I'm ready to find my answer. Use SOHCAHTOA. So I'm trying to find tangent. Well, tangent of 5 pi 6 is going to be equal to the opposite over the adjacent. Which one's the opposite? 1. Which one's the adjacent? Negative square root 3. And you are done. Now, there was a video about rationalizing denominators. Totally your option. You do not have to. But for those of you who want to, you could take 1 over negative square root 3 and multiply top and bottom by square root 3. And you would end up with square root 3 over 3. But there's a negative, so we make the whole thing negative. If I was doing big ideas, they would want that kind of answer. But it's okay. I totally will accept this one if you want to stop right there. Okay, example 2. Here we go. Step 1, draw the angle. Okay, I'm going to use a pencil so it doesn't get quite so messy this time. I'm going into fourths, so split the top half into 4 equal pieces. 1, 2, 3, 4. Split the bottom, 4 equal pieces. 1, 2, 3, 4. Done. Okay, now let's count up to 7 pi 4. So here we go. 1, 2, 3, 4, 5, 6, 7. Okay, this is the one I'm going to use. This is the angle 7 pi 4. What do? I draw a triangle that touches the x-axis, not the y. It has to touch the x-axis. Okay, so we're going to draw it this direction. There's my right triangle. All right, am I in fourths, sixths, or thirds? I'm in fourths. This reference angle right here is pi 4, which makes this a 45-degree angle right there. Okay? which means this is this triangle, but what? It's just been flipped and flipped, right? So make sure you get the hypotenuse. The one across the right angle is square root 2, and the two legs are 1 and 1. Check for negatives. I went right, that's positive. I went down, oh, that's negative. Hypotenuse is always positive. Okay, I have it labeled. Now use SOHCAHTOA. I am trying to find secant of 7 pi 4s. Secant is what? Hypotenuse over adjacent. We didn't label these. Let's label these quick. Okay, this one's my reference angle, so that makes this the opposite, this the adjacent, and this the hypotenuse. Okay, once again, x is always the adjacent, the x value, the y value is always the opposite. Okay, and this angle right here at the origin is always your reference angle. All right, so here we go. Hypotenuse, square root 2. Adjacent is 1, which is just equal to square root 2. And we found that. All right, guys, one more. Here we go. Hang in there. You can do it. All right, how do I find trig values using the unit circle? So here's the unit circle. All right, and I want to find trig values. So we're just going to remind you when using the unit circle, if you're trying to find sine, it's just equal to the y value. Cosine is the x. Tangent is y over x. Now, if you want to find the cosecant, it is 1 over the y value. Now, when we're dealing fractions, sometimes that gets a little messy. So another way to think about it, isn't 1 over y the reciprocal of y? Okay. It's taking whatever y is and we just flip it, right? So if my sine is a fraction, all I'm going to do is flip it. I'm just going to take the reciprocal. Secant is 1 over x. Once again, that means just to take the reciprocal. To take 1 over x means to take its reciprocal. Cotangent is x over y. All right, let's practice some. Cosine of 5 pi 4s. All right, go to your unit circle, find 5 pi 4s. Here it is. Okay, here are the coordinate, the ordered pair. Cosine is equal to the x value. Which one of these is the x? This is x, this is y. This is the x. Boom, that's my answer. Negative square root 2 over 2. All right, tangent. Tangent of 3 pi 4s. Go find 3 pi 4s. Here he is. Here's the ordered pair. Tangent says take the y divided by the x. Okay, that's what we're going to do. We're going to take square root 2 over 2 and divide it by negative square root 2 over 2. How do you divide fractions? Copy dot flip, you guys. We're going to do copy dot flip. So here we go. We are going to do square root 2 over 2 times negative 2 over square root 2. And what happens here? I can reduce, cross reduce those, cross reduce those. What if everything goes away? We're not left with 0, guys. What are we left with? 1, but there's a negative, so answer would be negative 1. If you divide something by itself, it does equal 1, but this you need to remember copy dot flip, because guess what? What if I asked for 7 pi 6? Those aren't going to cancel out as nicely, so you're going to have to copy dot flip if I asked you for one of those. All right, cosecant 7 pi 6. Go find 7 pi 6. Where is it? All right, right here. Do you see 7 pi 6? Here's the ordered pair. All right, cosecant. Cosecant says I want to take the reciprocal of the y value. Okay, which one's the y? The y is, I'm right here, you guys. The y is negative 1/2. So what is the reciprocal? What happens if I flip negative 1/2? I'm going to get negative 2 over 1. But what's 2 over 1? Just 2, so that is just equal to negative 2. All right, keep going. We're on a roll. Sine of pi halves. All right, pi halves. Where are my pi halves? Whoop. Can you see? Am I off my, up here? Pi halves. Here's my ordered pair. Sine is the y value. What's the y value up here? 1. Boom, I'm done. All right, cotangent pi. Cotangent is going to be the x over the y value. Okay, let's go find pi. Where's pi on my unit circle? Here we go. I'm over here. Look at this ordered pair. This is the x, this is the y. So when I do x over y, it's going to be negative 1 over 0. What is negative 1 divided by 0? Nah, no, we cannot divide by 0. The answer is not 0. The answer is not negative 1. It is undefined, you guys. You cannot divide by 0. All right, last one, secant of pi thirds. Secant is the reciprocal of the x. So come up here. Where is pi thirds? Let's take a look. Pi thirds, where are you? Right here. Okay, it says take the x. The x is right here, 1/2, and it says take the reciprocal. What happens if you flip 1/2? I get 2/1, which is just 2. All right, now some of you may ask a very important question. I hope you watch the whole video to the end so you hear this very, very, very important information here, okay? Some of you may say, well, isn't this the same as what I did here with the reference triangles? We're finding trig values. So yes, you're right. It's 2 different methods, okay? When I do section 2 right here, where I was drawing these little triangles with the reference triangles, it is finding the same thing that this big unit circle finds. And some people may say, well, do I have to draw the triangles? And the answer is, if the directions say it, yes, you do. And guess what? I am going to make it say it. So when you do this, I don't know why it went blurry all of a sudden, you guys. But that's the deal. On the test, there are going to be certain ones that say use a reference triangle. If it says use a reference triangle, I got to see this. I am looking for this. I'm giving points for this, okay? If the directions on the test say use a reference triangle to find the trig function, I better see you draw the angle. I better see your triangle. I better see the triangle labeled with all 3 sides, okay? If it says do it with the unit circle, then heck yeah. What I should see for the unit circle is like if there's some work to be shown, I better see some of that. All right? That's going to be the expectation. So you better know how to use this method and not only the unit circle method. That's the entire unit. The unit is learning how to use both methods. So do not rely solely on this one. All right, you guys, email me with any questions. Sign up for a Zoom meeting. I am doing one Thursday and Friday. If you need any help, get on there with me. I'm happy to help you. Good luck with your test, you guys. Bye.